brother. Okay, so today, guys, we are going to go ahead and solve for x or find roots of polynomials, maybe raised to the x to the fourth or x to the fifth, something we haven't done yet, right? We did x to the fourth, but it was in that perfect still quadratic style, right? Does that make sense to everybody? It had something nice and dandy and hooty hotties and yada yadas and moving this around and opening this stuff up. I thought I was all prepared and such, but I wasn't. Okay, so today, what we're going to do, actually let's start here. I'll just make one up. Make one up. So if I had 4x squared, now let's put a plus 6 over yonder. With a plus 14x right now. Hold on. Let's make that 11x. Okay. So first off, let's factor this for kicks and giggles, okay? We all like to factor, and if you don't, you better start liking it. Okay, so that's plus 24. Factors of 24 are 1, 24, 2, 12, 3, 8, 4, 6, 5 can't go, 6 on the other side. That shows that those are all the factors, correct? Is this anything new to anyone? Are we okay with this? Possibly okay with that book right there? Yeah. Okay, so notice 3 and 8 get me to be the 11, so I rewrite it. 4x squared plus 8x plus 3x plus 6, group, 4x, and I'm left with x plus 2, correct? What do these guys have in common? Plus 3, and I'm left with x plus 2. Pull out the x plus 2, and I'm left with 4x plus 3. Can somebody tell me the possible zeros, or what are the zeros of this one? Go ahead.
Negative 3/4 and negative 2.
Everybody understand where negative 3/4 comes from? Subtract the 3 divided by 4, right? Okay? Negative 2's right there. Pretty simple, okay? Right? Okay, I told you guys earlier, this isn't how I was taught to factor, correct? I was taught to factor by the hippo butts, or just jumping right into your parentheses, correct? To do your binomials. Okay, so this is the process that I had to do. I had to say, okay, 4x squared. All right, so here's my options, really. I either can have 4x and x, right? Because that gets to 4x squared. What's the possibilities of 6? 1 and 6, or 2 and 3, correct? So I'd have to say, oh, let's try a 6 here, and a 1 here, or whatever. It sucked. It was a pain in the butt. Well, let's just pretend I put my plus 1 here and my plus 6 here, and we all know that isn't going to be it, because that would be 24x plus x, which is 25x. That's not 25x. So this wouldn't work. But do you guys understand how this could be a possibility of why it was there? Maybe it's not right, but do you see why it's a possibility? Because technically the way I was taught is, how can I get to 4x squared? 4x times x. How do I get to 6? 1 and 6. Those how you get there, but then the middle terms didn't add up. Does that make sense what I'm trying to get at there? What would be the possible zero here? Negative 1/4 and negative 6. Well, is that the only way to get to 4x squared is by 4x and x? What's another way? 2x and 2x, right? And then I could either have a 2 and a 3, or I could have, like, maybe put a 3 here and a 2 here, or I could do the 1 here and the 6 here. You get the idea, correct? Notice, and that involves 1/2, or 3/2, if that was the case. According, but you got the idea, correct? Those are possibilities. Well, today, we are going to start with the possible rational zeros test. And where that comes from is up here. Okay, I'm going to skip it, and somebody tell me what I wrote again. 4x squared
Plus 11x.
plus 11x plus 6. Here is the rules. Did Caesar find you?
Yeah, he's going to.
Okay, so with this is the case. This is how you're going to go ahead and find the possible rational zeros. Okay? And it should make sense from what I just showed you. What our first goal is, and if you don't quite get what's happening right now, please stop and ask, because it's not mathematical really. It's more of a rule. I can show you where it comes from. I kind of already did. Okay, but if you want more of a connection, let me try to do that for you. Okay, so what you're going to do is you're going to take the constant. Okay? What are the factors of the constant? 1, 2, 3, 6, right? Now we don't know whether that was -1 and -6, so what we do is here put a plus or minus. Does that make sense? Because I didn't know if it was -2 times -3. I don't know if it's -1 times -6, +1 times 6. You get what I'm trying to get at. Okay. And then what we do is we divide it by the factors of 4. What's the factors of 4? 1, 2, and 4. Once again, plus or minus as well, correct? Everybody remember? Okay with this so far? Now, here's what we call our possible rational zeros. First off, what's rational mean? Things that can be written as a fraction, a ratio fraction, right? So is 2 considered a rational number? Yes, because that's 2 over 1, right? Everybody there with me? Understand what I'm trying to say by that? Okay, so here's my possible thing. You go ahead and take the factors of the constant. We're going to go ahead and divide them by the factors of the leading coefficient. Okay, so what's 1 divided by 1? 1. 2 divided by 1? 3 divided by 1? 3. And 6 divided by 1. Okay, now I'm going to go to the next number. What's 1 divided by 2? 1/2. 2 divided by 2 is already 1. It's already there, so I don't need to rewrite. Did you find them?
No.
I'm sorry. Did you turn them in? Give me a second. 3 divided by 2. And 6 divided by 2 is 3, so it's already currently there, correct? Is everybody there with me? Okay. What is 1 divided by 4? 1/4. 2 divided by 4 is already there. It's a half. 3 divided by 4 is 3/4. And 6 divided by 4 is 3/2. After school, can you visit me for a minute? Okay. Does everybody understand where these numbers are coming from? Once again, all I did was take these numbers and I divided by here. Now why? Now why? You might be saying, where does the half come from? It comes from 2x minus 1. Isn't that a possible binomial that I could have there? I could. If that was the case, I'd need to have a 2x and a minus 6. Now this is not correct to get that factor, right? Does everybody understand what I'm trying to say by that? It's not correct, but that's a possible value, right? Was the half, and that's where it came from. It's from that binomial. Where did the 3/4 come from? 4x minus 3, and then I need 4x minus 2. Do you see where that came from? Because notice, not 4x, sorry. 4x times x would be 4x squared. 4x times that would be -8x minus 3x. Oh, -11x, but I just need to switch those to pluses, and that's where it come from. Kind of get what I'm trying to say where these values, what these are. They're possible zeros for this equation. Now, when I'm in this case where I'm into a trinomial, is this worthwhile doing? No. We could factor that really simply, and we don't even have to do this. But, let's say we get to here, okay? Here's my first example of the. Hopefully that makes sense to what we're trying to do here. What can we see on this one really quick? Could we find the zeros of this one without doing the process that I'm going through? We could factor by grouping. Because every time I have 4 terms, does that mean I can factor by grouping? No. Yeah, it doesn't always necessarily mean that. Because if all of a sudden, let's pretend this guy was a 5x, could I now all of a sudden do that? No. Right? I couldn't factor by grouping in that case. Okay, so not always, but let's just kind of ignore that we could factor by grouping. Let's pretend I never taught you that skill before. Okay, so what I'm going to show you is how you would have to maybe go ahead and try to find it by doing the rational zeros test. Okay, so let's go ahead and find the possible rational zeros first. So once again, the process is find your constant, -2. What's the factors of -2? 1 and 2, and plus or minus, because we don't know which one has the plus and which one has the minus, do we? Does that make sense to everybody? Okay, what's the factors of 6?
Plus or minus 1, 2, 3.
Can you shut that door for me, Miss McKenna? I got it right? Yeah. Yeah. So notice, if you'll quickly see, that's 1, 2, that's 1/2. 2 over 2 is 1, that's 1/3. 2/3, 1/6, and 2 divided by 6 is 1/3. So these are all the possible rational roots. Notice there's actually 1, 2, 3, 4, 5, 6. So I times it by 2 because there's plus or minus. There's 12 possible rational roots. Yes, no, maybe so. Okay, 12 because notice you see how there's 6, but each of them could be plus or minus. So therefore we just double it. I am going to do synthetic division. First off, I have 6, -4, 3, -2. The first thing I ever do is I add the coefficients. Will somebody add those coefficients for me, please? Comes out to be 3, right? Awesome. Comes out to be 3. Okay? So what that tells me is, notice, ladies and gentlemen, if it comes out to be a 0, guess what's one of my factors? 1. Why? Because when I plug a 1 in for x, does that change the value of my coefficients? So therefore, if they add to be 0, I know 0 is a factor. Did it add to be 0? It didn't. It added to be 3. So is that not good information? No, it's still okay. 1, 3. Okay, now you might be saying, whoa, Mr. Roberts, why the heck are you writing that down? Because it could help us out. 1, 3. Okay, why I'm writing this is it tells me a point. Because remember, if it doesn't go into it nicely, it still tells me a value on the graph using the remainder theorem, right? So you remember how there was 3 left over? That tells me a point. 1 was our x value, 3 is now our y value. Okay, so I'm not going to pick 1. So let's try, what's another one? Let's try 2. Let's go ahead and just try 2. So we're going to do synthetic here. Now this is a lot of guess and check here, ladies and gentlemen. Now, if you could really factor by grouping, would you be doing this step?
No.
No, you wouldn't. Okay? This is what you would be doing on things that you wouldn't know how to factor. Okay? So I bring down the 6. 2 times 6.
Wait, where did you get the 6?
I just picked 2. It was out of my possible rational zeros. Anyone I could pick. I could pick a half, I could pick a third, I could pick 2/3, I could pick 6, whatever I so choose. Okay? 2 times 6? 12. 8. 16. 19. 38. 36. Okay, ladies and gentlemen, boys and girls. Okay? Something here that's nice. You see how there's no sign change down here? Obviously there's no numbers larger than that, but in any other case, let's pretend there was like maybe 1, 2, 3, and 6 as our factors on top, okay? Does that make sense? If there's no sign change, that means there's no other numbers higher than that as a 0. Okay, so you might want to look for that. There's some things to look at as we're going through. Okay. Let's go ahead and, once again, like I said, this is sometimes just a guess and check, and it is a tedious process sometimes, okay? I'll be honest with you. So I'm going to keep that number. What was it again? 6, -4, 3, and -2. Is that pretty good with it? What's a number anybody want to try? Anybody want to try one? 3? You can't pick 3. A half? 2/3? We'll try 2/3.
What? You want to try half?
I kind of just did it through my head really quickly.
Okay, that's fine.
Well, as I do a half, that's 6. What's 6 times a half? 3. 3 and -4 and 3, that's a 1, and then I get a fraction. Usually not going to be the case. You could. Not usually. I'm going to try 2/3. So that's 6. 2/3 times 6 is 4. That's a 0. That's a 0. That's a 3. And that becomes a 2, which is a 0. So is 2/3 a factor? It is. Now, once again, pretend that we didn't know how to factor by grouping. Okay? What was this? This was a x cubed, correct? What is this? X squared. So now I'm at 6x squared plus 3. Okay? There was one of them, and then notice because I have 2/3, does everybody understand that would be 3x minus 2? Nope, other way around. Nope, that's right.
Wait, why would it be x plus 3
Well,
and 2 squared?
from right, because this could also be x minus 2/3, and that's probably what it is in this fashion. But anyway, how this comes down is because remember, if this was x cubed, if it goes into it evenly, that means it was x, right? We're going to divide it by x, so therefore that's 1 degree less. You with me on that? Remember, that's what we discussed last time. Okay, so what are my zeros? What's the zero of this guy? 2/3. Does everybody understand that? What's the zero of this guy? So we set him equal to 0. X squared equals -3/6, which is -1/2, right? Right there. How do I get rid of the squared? Square root it. Help you out there. Oops, a little too high. So x would equal plus or minus square root of -1/2, which is plus or minus I root 2/2. And notice, those would be my zeros. Okay? Now, I went through a harder process this time. Okay? If I saw the factor by grouping, would I do this process again? No, I'm just trying to show you one that kind of worked. Okay?
Okay, so after you did the synthetic division and you like do your equation, how do you keep these? How do you have two threes and then I get the 1, 3, the constant 3, and how do you do the 3x and you then do
This guy right here?
that one?
Okay, so this is from here.
Yeah, I understand that.
Okay, just making sure.
Yeah. I just
This-
understand that comes from.
This from here. Okay, because if I had x equals 2/3, because remember it said equal to 0, so I times by 3. And I want this to be a 0.
Oh.
Does that make sense? Yes.
How did x
How does this become root 2/2? Okay, so this is I over root 2, right? Do we like square roots in our denominator? So I have to rationalize it by taking square root of top and bottom. You with me in there? So therefore, square root of 2 times I is square root of 2i. Square root of 2 times square root of 2 is, you know, that's nothing yet. That's something that we learned last year, hopefully. Hopefully. Unit circle looks like unit circle, right?
Well, how did you know that 2 and 3 was?
How did I know it was a root?
Yeah.
Because it ended in a 0.
So if it ends in a 0, that's ends in 0. What if there's a value with every 0?
Great. Still cool.
Like,
What would you do if that was the case? Then it's in a quadratic, right? And then if you couldn't factor that quadratic, what would you do? If you can't factor quadratics, how do you solve them? Quadratic formula. Does that answer your question? Okay. Let's do another one. Okay, the whole goal today is to find those zeros. Now, you guys remember when I picked that point 1, 3 and I set it off to the side? Let's just say that. Let's just pretend, okay, once again, I'm a pretender sometimes, because maybe I don't always get to things. Let's say I picked 3 and I got 3, -2. Why is this information important? Go ahead, sir.
It is a point on the graph.
They are points on the graph. So knowing that this is a point on the graph, let's assume once again, 1, 3, somewhere up there, right? 3, -2 is down there. Is this graph stop or does it always continue one continuous flow? It has a flow, right? And it's continuous is what we call it. So as it continues, what did it just do? Drops. So therefore, I know there is a 0 in between 1 and 3. Now, does it have to be a rational 0? Could it be an irrational 0? Sure. But at least that kind of guides me to maybe another thing I would pick. So let's just say 1, 2, and 3 were options. I picked 1, I picked 3. What's another number that I'd probably check to see? I picked 2 because there is a number between 1 and 3 that crosses it, right? And 2 might be it. You guys kind of see why this is still good information, even though it didn't work, it's still useful information. Okay, to maybe help us. Does that make sense? Hopefully we get the next one right on, but it is what it is. Okay, let's do another one, shall we? Here we go, here we go, here we go now. Ooh, we like this one. No, it's actually, it's a lot easier than our last one. Now, you might not think it is, but it is. Okay, x to the fifth plus x cubed plus 2x squared minus 12x plus 8. Okay, so have I taught you how to solve anything with x to the fifth? Have I ever showed you how to find those? Nope, I haven't. So, besides doing it this way, or using my calculator, obviously using your calculator, finding the zeros where it crosses the x-axis, that's a way, right? But on the test, I will be asking you to find the zeros. Okay? All right, so let's go ahead and find our possible zeros, possible rational zeros. What could they be? Plus or minus 1, 2, 4, 8 divided by plus or minus 1. So basically, what's our possible rational zeros? Plus or minus 1, 2, 4, 8. So how many possible choices are there? 8, because of the plus or minus. Everybody good with that? There's possible 8 rational choices. Okay? So we go to synthetic. 1. Then what?
0.
How many of you guys forgot that on the test? There was a problem on there. So if you didn't, zero.
I noticed.
Do you see it was out of order as well?
Gosh.
You gotta see if you're paying attention. Okay. What's the first thing I'm gonna add? Always the coefficients. Add them every time because that's the easiest thing to find. If it is 1, if 1 is a factor, add the coefficients. Quickly, what do we get?
0.
Hot dog, huh? We're excited. We already know one of them. How many are there possible? Do they all have to be rational roots? No. Some could be irrational, some could be complex, right? Okay? So I do know one's going to go because I added the coefficients and it ended up being 0. So now we'll just do the math. 1, 0. Oh, that's a 1. Sorry. 1, 1, 2, 2. 4, 4, negative 8, and 0. Okay. So what is this technically saying right here? Can anybody tell me what this says right here? I'm going to hold off.
It's
Go ahead.
x to the 4th plus x to the 3rd plus 2x squared plus 4x minus 3.
Awesome, Tassi. He said x to the 4th plus x cubed plus 2x squared plus 4x minus 8. Does everybody see why that's the case? Because once again, we go down 1 degree. That was x to the 5th. This is now x to the 4th. Because I picked 1, will 1 not work again? Can we have a multiplicity? So what's the next thing you're going to try? Add the coefficients. What's the coefficients if I add them again?
0.
So what are we going to try again? 1, this one right here. Always keep going down because we're going to try to keep going down. Because right now, it's still hard to solve a, you get a quartic, right?
Yeah.
Still kind of hard. So, try it again. So we're going to try 1 because we added these coefficients together and it got us a 0. Right? So I do it 1, a 1, a 1, a 2, a 2, a 4, a 4, an 8, an 8, and 0. Ladies and gentlemen, what are my zeros as of right now? 1. They're 1. Multiplicity of 2 so far, right? But they are 1. Correct? Yes, no?
If we wrote it down, like writing down the x plus 1.
X minus 1 squared.
Yeah, we could do that, right?
Good? This is how, if I asked you to write it in factored form, you would have it as x minus 1 squared. Okay? Okay. Ladies and gentlemen, can somebody read this to me? And we're going to stop right here on this one because we can see an easier way. What does that say to me? Because notice I went x to the 5th, what's this guy? X to the 4th, what's this guy? X to the 3rd. 4 terms, x to the 3rd. Let's see if we can factor by grouping because it's something maybe we're familiar with, correct? So I have x cubed plus 2x squared plus 4x plus 8. Is it something we can factor by grouping?
Yep.
It is, isn't it? So I grouped the front two. What do those guys have in common?
Squared.
And once again, factoring is not going away. That is a big part of this test. So if you struggle, once again, please either A, come and get some help, or do something of the sort. So that would be x plus 2. What do these guys have in common? 4. So therefore, I pull out the x plus 2, x squared plus 4. This guy comes down, x minus 1, quantity squared, right? Where did that guy come from? From our previous ones we already found, right, Hannah? Yes, no, maybe so. Am I allowed? I'm not trying to be fast, guys. If I'm fast, let me know. Is everybody okay? Okay? Okay. Well, notice here's 2 of my zeros. Here's my third 0, and then I'll have 2 here because it's x squared, right? So is that my total of 5?
Yeah.
Okay. Little side note here. What is the value of this if I wanted to factor this? That's part of your homework today, is factoring complex roots. Because is that a difference of squares?
No.
That's called the sum of squares. Can we go ahead and factor sum of squares? We can't until I just learned this summer. That was pretty cool. I was like, oh yeah, something I learned. Okay, so x squared plus 4. Can somebody tell me what I squared is?
1.
Negative 1, right? So since this is this, couldn't I write x squared to be minus a 4i squared?
I don't like that
Now you might not like that, but does everybody see that? Because what is I squared?
Negative 1.
Negative 1, and negative 1 times negative 4? Did I change the value of the expression? Now what is this called? Now it's a difference of squares, isn't it? And I can factor that, can't I? To be what? X minus 2i, x plus 2i, and I would get these values anyway if I went ahead and set him equal to 0. I noticed a lot of people forgot their pluses and minuses. I don't know in this class, but like I said, as I'm grading the other guy, the other people's, they're forgetting their plus and minuses quite a bit. Anytime we take an even root, you need to do plus or minus. Okay, see I have 2i, but notice if I factored it as well, I got 2i and negative 2i as well, correct? That is a skill I want you to start looking into. Okay? Is everybody there with me? So notice, what are my zeros? If I ask you for my zeros, what are they?
1. Plus or minus 2i. And negative 2.
There you go. Those are my zeros. Now there's only 4 there, but why is there 4 and there's a 5th degree polynomial? Because 1 has a multiplicity of 2. Any questions on that?
Where does the negative 2 come from?
The negative 2 comes from.
Oh, okay.
You okay with that? And it was also one of our. Was it one of our? No, it wasn't one of our factors. Notice, look, we found every 0 or all zeros of a 5th term polynomial, a 5th degree polynomial, right? Have you guys ever done that before?
I like this.
Was it that hard? Is it tedious? I will say yes.
Is it going to be the same process, like if you were like x to the 10th?
X to the 10th, we aren't going to go that high, but yes, you would do that process. That would kind of, yeah. But that's the same process. You could keep whittling it down.
So we need to use this formula on anything that's above.
I would say x to the 3rd, unless they pull something out that they have in common.
Okay.
Because like I gave you guys an x to the 5th on the test, but they all had something in common to pull out. Does that make sense? Or that x to the 8th one, I don't know if we did it on that one, but we had one on your homework, was x to the 8th, x to the 4th, and then a constant because we did the u substitution. Do you remember that one?
Yeah.
Okay, is everybody good there? We feeling comfy? We doing all right? Hopefully today is a day that you're not like going way over your head. Hopefully there's not a flyby today. Okay. So, what if I told you guys something like this? hold on. Oh, there's a good one. I like that one. Yep. We'll come back to you. Where are you? Oh, we'll come to you. We like you. Sorry, I like talking to people. And sometimes that Peterson is just me. Nobody else can talk to me. We're going to do this one. That's a 2x cubed plus 3x squared minus 8x plus 3. This is a prime example. Can I factor by grouping? I can. These guys have an x squared, and if I pull out an x squared, I'm left with 2x plus 3. Does 8 and 3 even have a number to pull out to get 2x plus 3 somewhere? No. So I can't factor by grouping. So this is a prime example of why when you see a four-termer, doesn't mean that we're always going to factor by grouping. Make sense what I'm trying to say? Okay. I would like us to list the possible rational zeros. What are we going to do? Kelsey, right? What's the possible factors here? 3 and 1, right? Does that make sense to you? Just the factors of 1 times 3 gets 3. You okay with that? How about the factors of 2? Awesome. Okay. And then what do we do with this process, James, that you're closing your eyes on me?
Sorry.
You're all right. Just helping you out. It's not cold enough in here today. So we go 1 divided by 1 is 1. 3 divided by 1 is 3. 1 divided by 2 is 1/2. But we needed the 3/2 anyway, didn't we? Can everybody see where that's at? Are you okay, Maddie? Am I blowing you out of the water? It's like a bomb.
No, it's just crazy in here.
I am like sweating. Wow, I put deodorant on. So we do 2, 3, -8, 3. First thing we should do is what? And what do we get when we add them?
0.
So that's nice. Is that always going to happen?
No.
No, please understand that's not always going to happen. Okay? But it does this time, doesn't it? Does everybody understand what I'm trying to say by that? If you don't, let me explain why. If I plug a 1 in here, what does this number become? 1 cubed becomes 1. 1 times 2 becomes the 2, right? 1 squared is 1. 1 times 3 is still 3, so I just add those together anyway, wouldn't I? 1 times -8 is -8, plus the 3, add those together. That's still the value of plugging 1 in there, correct? So that's why if you add the coefficients, that'll tell you if one is a factor by having a 0 there. If it comes out to be 0, it is a factor. Yes, sir.
So 1 is a factor?
1 is a factor. See, watch. If we do it again, 2, 5, 5, -3, -3, 0. Okay? I went from x cubed down to what now? And that's always our goal, for sure. If we can get down to an x squared for sure, we know we're done. Why? Because we can either factor or quadratic it. When we get to there, we are good to go. Does that make sense? Okay, so we are at 2x squared plus 5x minus 3. Me right now, I can jump right down into my hippo butts because I'm a master of factoring. Do you guys want me to factor this, or for time's sake, can I just kind of do it? Okay, watch. We have a 2x here and an x here. Does that make sense? Because that's the only way you get to 2x squared, correct? What's the only way you get to a 3? 1 and 3. So now I got to dictate which one gets the 1 and which one gets the 3. Okay, I need to get a 5x. So therefore, I need to get this guy to be a positive 6. That's where the 6x comes in, right? And then I subtract the 1. Now, we should all be able to get there. If I asked you to write it in factored form, what would I have? Is this in factored form?
No.
Because I'm missing my other 0, which would be x minus 1. That would be factored form. Anybody have a question where I'm at there? James. Just trying to help you out, brother. You might want to stand up, do some jumping jacks. What are my zeros? 1, a half, and -3. Those are my zeros. Any questions? Kicking its butt, taking its name, right? Sir, yes, sir.
Where did the x minus 1 come from?
X minus 1, if I wanted to put it in factored form, we already noticed that 1 was a factor, so therefore I put that down in as a factor. Answer your question? My grandpa, when I was younger, if I didn't cover my mouth, that's what he'd do. BAM! He'd touch your UV left back in the back. But then the next guy, and I didn't do that, but there's many a days I choke. I'll be alright, you're okay. Everybody good there? Okay, now let's get to a little harder stuff. When you do the quadratic formula, and it's still complex, so like for here, let's say it came out to be 1 plus or minus square root of negative 4 over 3. Let's just pretend that's what it was. Okay? How many solutions are there? 2, because I have 1 plus or minus 2i over 3, which one of my solutions would be 1 plus 2i over 3, and the other one would be 1 minus 2i over 3. Now notice, if you'll look here, what are they? These are called conjugate pairs, aren't they? Same number, what's the difference? The sign in the middle. Okay? This needs to go in your notes. Complex zeros always come in conjugate pairs. Complex zeros always come in conjugate pairs.
That sounds like it could be wrong.
Irrational zeros always come in conjugate pairs. Complex and irrational always come in conjugate pairs.
You said rational numbers?
Irrational. If I said rational, I apologize. Irrational. So give me an example of an irrational number. Square root of 5, right? Pi. Okay? Hopefully pi is never one of our zeros. Okay, so here is something that you could do. Okay, this is a great question. If I said, write me an equation of 4th degree, if I told you 2i is a 0 and root 3 is a 0. Please write an equation of 4th degree if I give you these two zeros. How am I going to do that? Well, what else do I know is a 0?
Negative 2i.
I also know negative 2i is a 0, don't I? And who else? Negative root 3 is a 0 as well. They always come in conjugate pairs. Now notice I have 4 zeros. With 4 zeros, what can I write? A 4th term polynomial. How do I do that? Well, once again, what did you do when I said x equals 3? Somebody tell me, what would you do here? You went x minus 3, right? So it's the same thing. What am I going to do with this guy? X minus 2i. This guy's going to become x plus 2i. Anybody have a question so far where I'm at? What about this guy?
X minus
Right? And then x plus square root of 3. Everybody good there? Do we know how to multiply? What are these called again? Conjugates. Whenever you see conjugates, you should be jumping up and down. Okay, conjugates are perfect to multiply. Because what happens is, when you multiply the front guys, you get x squared, right? Here and here. Is everybody there with me? What happens to the inner and outside part of FOIL? Watch. X times 2i. 2ix. Negative 2i times x. Negative 2ix. So I have positive 2ix and a negative 2ix. They will always reduce out. Okay, that's always what's going to happen on complex if you have conjugate pairs. And then notice I go, oh, negative 2i times a positive 2i, negative 4i squared, which is plus 4. Everybody there with me? Let's do this one then with kind of just thinking. X times x, x squared, minus 3. Because it would be a negative times a positive, right, Tossie?
Yeah.
And then root 3 times root 3 would be 3. Because that's root 9, right?
Yeah. What happened to the I?
because once again it became negative 4i squared, right? And what is I squared again, Hayden? Negative 1 times negative 4. That's where you went. Good question. Everybody good? We doing okay? Okay guys, hopefully I'm not, like I said, I'm not trying to speed up. I just want to, this is just me getting in my inner math nerd and I just start going and I get all excited.
Why? I don't understand.
Why not? Unless they choose to. Doesn't have
Well, math teachers have more going on. That's why.
Everybody see what I got? I just spoiled those two, right? So therefore my fourth term polynomial, there it is.
Oh.
And I wrote that because of conjugate pairs, right? We're doing good still. Thanks for keep looking up at there, because every time you do, I'm like, is anywhere close?
Wait, what?
Ethan tells me a lot of words just with his eyes. You might not say them, but he's there.
I might have taken off his words.
Okay. So, with that being said, ladies and gentlemen, we are now going to go jump in a creek. Let me find one really quick. You don't want to go jump in a creek? You guys are so mean.
Jump in a creek?
Oh! I'm so excited. You know, all these things are fun to do with I don't know. I'm making it up. Any home handwriting questions on that? I'm going to even give you a 0 today. I'm going to tell you one of the zeros. How many zeros should there be? 4. And I'm going to tell you that is a 0. How is that helpful? There's 2 options. Option number 1, do synthetic with this being your 0 to go through. I prefer that way. Option number 2, put it into, what else is a 0 then? I could go ahead and put it into my 2 binomials, right? Does everybody understand what I'm saying about that?
Yeah.
Go ahead and FOIL that through, kind of like I did, right?
Yeah.
And then I do long division. You guys make that choice. Because then after I get this, this will come out to be x squared plus 4 after you do it. I could just go ahead and do long division here, because if I divide this by this, that should tell me what's left over. I've showed you. You ready? You guys ready? We're going to do synthetic. 2, negative 1, 7, negative 4, negative 4. You might want to give yourself a little bit space more than I did there. Because this is imaginary numbers, and so you're going to have some complexer numbers. So I could use 2i or negative 2i, whatever one you want to start with. What would you prefer? Let's use a 2i. So what's the same process? Do the same things, just is going to look a little bit different. Okay? Bring down the 2. Is this helping you on the day? Were you here for synthetic?
Oh, that's a 2.
Yeah. So that's a 4i.
That totally changed my word.
Everybody see where that's a 4i at? Yes or no? So then notice this would be negative 1 plus 4i.
Oh, okay.
What do we do? Because isn't the process of the synthetic bring down, multiply, add? But I can't add negative 1 and 4i. They're not like terms, are they?
No.
Are you from Ohio? Okay, I'll give you that then. It's just not a big Ohio state.
What?
Anyway, onward. Okay, then we multiply again, correct?
Yeah.
2i times negative 1,
2i,
negative 2i. 2i times 4i, 8i squared, which is negative 8. So 7 minus 8 is negative 1 minus 2i. Where did I, if I lost you, please let me help you. Okay, let's go over the process again. I'm going to go step by step, see if you can catch up. Here we go. Bring down the 2. That's our normal thing. What do we do in synthetic? We go this times this, correct? 2i times 2, 4i. Negative 1 plus 4i is negative 1 plus 4i. Now I have to do this to this whole binomial. So what's 2i times negative 1? Negative 2i. 2i times 4i, 8i squared. And what is I squared again? Negative 1, so that becomes the negative 8. Yes, no, maybe so.
Yes.
We okay? Okay. 7 minus 8 is negative 1 with the negative 2i. 2i times negative 1 is negative 2i. Now 2i times a negative 2i becomes a negative 4i squared, which then comes into be 4. Negative 4 plus 4, 0 minus 2i is just negative 2i. And negative 2i times 2i becomes negative 4i squared, which is 4. Negative 4 plus 4 is 0. That shows that it is a factor, and it should be because that's what they told me, right? It was a 0. It was a factor. Right? It better gosh darn be 0. If not, you did something wrong. Correct? So now you say to yourself, holy freaking moly, I have to do that again. Actually, it's a lot simpler on the second one. So what am I going to do? Not 2i, I'm going to do negative 2i. And watch how easy this guy is. This guy's a whole lot easier. Negative 2i times 2. That comes to be negative 1. That becomes 2i. That becomes negative 1. That becomes 2i. That becomes 0. A whole lot nicer. The second guy goes a lot faster. Okay? Are we okay with that? Do you have to do it this way? Could you do the long division?
Yeah.
Do you guys want me to do the long division really quickly?
No.
Really quickly.
I just count through that thing. I'll be like, bam! You know what I mean?
Really?
Ethan or Hayden? Who had their hand?
I did. Why would you do negative 2i?
Because once again, what about complex roots? What do they always come in? Conjugate pairs. So if I gave you 2i, I automatically know negative 2i is also a 0. Does that make sense? So therefore, out of my 4 zeros, I already know 2 of them. So I did synthetic twice. This guy was x to the 4th. What's this guy? What's this guy? Squared. And so what can I do at the x squared stage? I know this is 2x squared minus x minus 1, and I can factor, or quadratic formula. Yes, ma'am?
Okay, so would it have mattered if you did on the first one
Nope.
negative 2i or okay?
And when obviously, you change these coefficients here, obviously, right?
But at the
From
end,
here to there.
yeah.
This one will be the same, but I'm saying like this
Yeah.
stuff would have been different.
But in the end,
You're going to still get the same, yep.
Okay.
Did I see another hand somewhere? Yes, sir.
I mean, just wondering how you can take like the answers from the bottom.
And how I can keep decreasing it by a degree.
No.
Oh.
No. I can take the one from the bottom and then put it in the equation.
That's basically how you're deciding how I got to 2x squared minus x minus 1, right? Because once again, each time I divide it, it is telling me the coefficients of a term less. Because when I do long division, okay, this is basically doing a shorter version of long division, okay, without all the x's. I'm basically asking, how does x become x to the 4th, 2x to the 4th? I need a 2x cubed. These are just 1 degree less and 1 power as you go along. It's just lining them up without the variables.
And so the one below it is 2x squared.
Because this guy was x to the 4th up here. That guy was x to the 4th. I did synthetic once, so that means I'm down in x cubed. I do it another time, that's x squared. If I did it one more time, what would it be? Be at x. But I'm not going to do that, because as soon as you're at quadratic, stop and go to factoring or quadratic formula.
So how does that come out to be 2x squared minus x minus 1?
Because once again, this was 2x cubed, so therefore I drop down a power, 2x squared minus x minus 1. I'm just going down by a degree each time as I move to the right. Okay?
So like when you're doing the synthetic thing or whatever, if you just do it until you get to the square.
I would suggest get it till you get to the squared. Because that squared, what can we always do? Quadratic or formula, or factoring, right? Not unless you see something here at this stage to do factor by group. Okay? Okay, and once again, this factors really nicely. Get my hippo butts over here. So we have a 2x and an x. I need a -1, so therefore this is a -1, that's a plus. And I'm, once again, I've done this a lot longer. I can do that quicker. Please factor one way or the other, right? Quadratic if you need to, I don't care. Okay, and then notice if I wanted in factored form, x minus 2i, x plus 2i. That's also values. And then we could say our zeros are what? Plus or minus 2i, 1 and -1/2. Those are our 4 zeros. So when I say x to the 5th, gosh darn it, how many zeros better you have? 5. Could you have multiplicity? You could, right? Okay. We might have one last thing to talk about, Descartes' rule of signs. Okay? It's also pretty cool.
What?
I think let me see how it's spelled. I think that's how it's spelled. Descartes. Descartes. Let me see. Descartes. S.
I admire your handwriting.
It's okay.
TESS.
There's a double S. There needs to be an S.
Your writing is incredible.
I know. I try for my hardest, and we work on it really well.
Okay, Descartes' rule
Of signs.
Rule.
Rule, like R-U-L-E.
Yep.
Can't you see the R, the U, and the L and the E?
Well, I saw the R.
How do you spell this first word?
Descartes apostrophe S. Descartes' rule of signs. It can also be helpful in deciding on when and where to go ahead and when and where. What's up? You are more than welcome to listen. Love you with a passion, man.
Someone's crying.
Okay, so here's an equation. Now, this Descartes' rule of signs tells us this. It tells us how many positive zeros we're going to have and how many negative zeros we're going to have. Okay? Here's the rule. Look at the equation. How many times does my sign change as I go from degree to from coefficient to coefficient? Is this a sign change? From positive to a negative? Yep, so that's one sign change. How about from -5 to 6?
Yep.
That's another sign change. How about from 6 to 4?
Yep.
So we have 3 or 1 positive zero. Let me explain what that means. Okay? See how I have 3 sign changes going from a positive, negative, and my coefficient. Does everybody understand that? Branson?
Yes, value.
3 to -5, -5 to 6, 6 to -4, that's switching my signs. One goes from positive to negative and so forth. Okay, why does it go down by 2? Well, complex numbers come in pairs of 2s. So if I have 1 positive zero, I could have 2 complex numbers. So hence why I'd only have 1. Could I have all 3 positive? Sure. Would they be more than 3? No, because it's degree 3. Everybody there with me?
So, how many other sign changes do you use?
That tells you the positive. Let me hurry and finish really quick, and then I can answer. Okay. The next thing I'm going to do is switch the sign. So I'm going to change this from x to -x. Would that change the value of this equation if I did this from an x to a -x in here? Would any cube thing change it? Yes, it would. So therefore, this would become -3x cubed. How about an x squared? Would that change the value of my coefficient?
No.
Because negative and then something squared always becomes whatever it was originally, right?
Yeah.
So that becomes -5x. How about this guy? Would he change?
Wait, how can you have to display?
Oh, thank you. Apologize.
I'm so
No, you're awesome.
Go.
Is there any sign changes here?
No, there's no.
No. So guess what? There are 0 negative zeros. So remember when we did our possible rational zeros? Right?
Yeah.
and I had the plus or minus, on this one, I don't even look at any negative number.
But you said on the negative
You do?
3 cubes.
Okay, well, okay, watch what I did here. Okay, before everybody gets psychedelic on me, how I got to this is I went from my original equation, which was 3, and I just plugged in negative x. That's all I did.
Is there any sign change?
That would be a sign change.
Hold on, 1 second. What was this? Originally a plus, right? So when I simplify, it simplified to this guy. Not sign changes. I see what you're saying. Okay, Amber, you're saying, well, it went from a positive to a negative. No, that's not what I'm saying. So now look at this equation after I plug the negative x in.
Oh, okay.
Is there any sign changes? There's negative 3 to negative 5. Was that a sign change? Still negative. From negative 5 to negative 6, is that a sign change? How about negative 6 to negative 4? Is there a sign change? No. So notice, guys, see how this test plus the possible rational zeros test can help eliminate some possible zeros to pick from? Because right here, I have 0, negative 0. So any negative number is not going to work. It doesn't matter because there's no negative zeros. They're all positive.
So this won't have like a conjugate in it.
So it could have all 3 positive, right? Or it could have 1 positive and 2 imaginary. Because that gives me a total of 3. Now what if all of a sudden, okay, let's just pretend, I go ahead and I find 1 positive number. Should I search for another one? Well, first off, that 1 positive number gets me down to a quadratic. I'll just factor. But let's say we keep going. If I find 1 and I find another one, there's 2. What do I automatically know? There's another one because there's 3 positive. We can't just stop on 2. We could go ahead and find that third one. Does that make sense? And sometimes you'll have like 3 or 1 positive or 3 or 1 negative, so you know there's at least 1 positive and 1 negative. Do you get what I'm saying? So it kind of helps on your searching choices. Okay? Yes, no?
Yeah.
Okay.
Mr.